Hey YouTube, welcome back. Today we have this problem. Binary tree path is that given the root of a binary tree, return all root to leaf path in any order. A leaf is a node with no children. So we have this specific tree, and basically we are returning like 1 to 5. We should returning like that, and we have another array. The left, we put the left and the right. And let's just start into some sketching so we will understand how we can approach this problem better. And let's just, where is the pen? Okay, this is a pen. So let's just say that we have, let's say that 1, 1, 2, 5, and 1, 3. Okay, 1, 2, 5, and 3, this one. So the point of that, if you want to return it, like, let's just take this one, the output, and let's put the output here. If we want to get this output from this array, we have two solutions that we have. We can do recursions, or we can just do iteration and loop through it. And I prefer to do recursions because recursions, I guess, if you have any problem, but this is only when you are training for the interviews. In your specific interview, you just make your interviewer choose what is best. If you have any problem that is you are recursion or you can iterative, I just highly recommend to use recursion, because in the future we will work a lot with the dynamic programming, and a dynamic programming is a highly like you will get a lot of problem solving in your interviews, that including but dynamic programming, specifically if you are going for mid or senior positions. So by training a lot on recursions, that will improve your skills when it comes to dynamic programming, because dynamic programming is about recursion, memoization, and break this the specific problem to sub problems. So we can go with the recursions, and I guess it will be O of n. Also the iteration, it will be O of n. So what we're going to do is that we first assign this one, and this will be our root. And after that, we'll say, do we have left or do we have right? It's a yes, we have right. So right will be our root, but we will create something called path, and this path, it will equals 1, and we'll say this path equals has no, we stayed with the left first. Okay, it doesn't matter. This path has left and right. If it has left or right, just add to this string and continue. And the 3, it will be the new root. And after that, I will say, okay, and I will pass to it the path, and I will say that 3 has left and right, and if 3 has left and right, I will not add to it this one, this simple. I will just add it directly. So I will have 1, 3, and after that I will do the left side in the same way. So let's just start in the code. I guess the code, it will be pretty easy. So as we are saying all the time, we are let's just I wanna create a function. Let's function I will say function construct I guess, but and it will have root and path, and the previous paths, or like let's say that not previous, the array, and this array will be the array of paths, and the path, it will be the path of the specific root, and the root is the specific node that we are currently looping in. And I guess I will create let array equals empty, and we return this array, and I will call the function, this function over, or I will call it, and I will give it the root, and the path, I guess it will be empty string, and the paths, which will be the array, and I will start into the coding. I will say if first of all this one, it will be a recursive function. So what we should do all the time when we have a recursive function, we should find our base case. And I guess our base case right now, specifically if you are working with a tree and you're just going node by node, you could, or like it's best for you is that to make your base case based on the root or the node. So I'm saying that if root doesn't equals null, let's just start working. I could say maybe if node equals null, return something, but just this is also will work. I will say the path. Yeah, if root equals null, I'm return nothing. Yeah, return, and yeah, basically that's it. I will say the path will equals, I will add to the path the root, the value, because each time we see the first of things first, each path starts with a value. So I will add to it root the value. Okay, and dot val, not value. Yeah, it's dot val, sorry, not value, dot val. And yeah, it's a number, so it will be dot string, dot to string, dot to string. And we will do like if we have left or right, if we don't have left or right, just we don't have, like for this example, like for node number 5, there is no left or right, so there is no need to add this arrow, because right now the next step is to determine if we should add the arrow or not. So I'm saying if root dot left equals null, and root dot right equals null, that means we reach the root to leaf, basically. Path array dot push this path, we are pushing this path, else that mean we didn't reach the root of leaf. So we continue calling the recursive function until we reach it, basically, until we reach the root of leaf. So what I'm going to say that first of all, if we are not into root to leaf, that means that we should add the arrow, because we have left and right. So I will say path plus, no, sorry, plus equals, I will add to it, and I will call this function, and I guess that we call it in the left side first, because they wanted to call it on the left side. It will be root the left, and I will put the path to it, and I will put the array. and it will be the same, but it will be root dot right. And I guess that's it. The output is oh uh-huh sorry. If root equals null, return nothing. Sorry. Yeah, okay, it worked. So let's just talk about how this worked. Let me just delete this for a second so the code will be in the middle of the screen. Um, First of all, we have the array, and we are returning this array, and we have a function that we calling to, so this function will modify this array. So we pass the array to the function, we have the root, and we are passing the path, which is be the empty string at the beginning. And we're saying that for this example that we have here, our root is equals 1, okay, and our path equals empty string, and the array equals empty array. So this is our first recursive function. This is our function that we call it from the binary tree. So we're saying that if root equals null, no, actually the root doesn't equal null. And we are saying all the time, when we have a recursive function, we want to make sure that we are putting the base case first, because we don't want our function to just keep running endlessly. So we first of all we have path, this specific variable, and this specific variable will be this one, this string. So we want to get this string right. So this string has two main values, the specific value of the current root and the row. And we first of all start with the adding the value. So we add path plus or equals, we add to it the value. So when we do that, the path will equals 1. And we said that if root.left equals null and root.right equals null, we just put the path directly. But for this one, the root doesn't equal the left and right. We have left and right for root 1. So what we are going to do is that if we have left and right, that means we should add the row. So we add this to the row. We add this. We add a row to the string. So it will equals right now. The path right now, it will equals like that. And we run this function again on the left side. So let's just run this function first on the left side. So first we put the root.left. So right now root, it will be equals root.left. So it will be 2. So the root, it will equals be 2, and we are putting the path and the array the same, so we can modify them. So I'm saying that path plus equals root the value to a string. So I'm adding to the path the value of the current root, which is 2. And I'm saying that if root.left equals null and root.right equals null, array.push path. However, we have root.right, so this is not true. So we continue. Else we add the row. That means the row, because we have left and right, so we add the row. And I'm saying run this one in the left, but we don't have a left. So if root equals null return, so this one will return nothing. And we return this one. We run this one on the right side. So when we run on the right side, it will be right now our root will be 5. So first we add the root value to string. We add the value to the path, so the path will equals 5. And I'm saying that root.left equals null. Yeah, for 5 there is no left and there is no right. So I am array.push path. That means we reach the root to leave. So that means our array will looks like that. And when we finish the left side, we go back, way more back to root 1, and we start with the right side because we finished the left, and we start with 3. So right now we in 3 the root will equal 3. However, if you remember the path in the first one, when we call it in 2, it was the same basically. So if you have it in 1, because look at, just because sometimes people will not be focused about that. The path in 1 that we are sending to 2 is it was equals like that 1, and we have arrow, and also the path that you are sending to left, it will be the same. So right now, because of that, I deleted most of the path. So I say that we have root right now. So we add path plus equals to the toString, so our root will equals like that. And I'm saying if root the left, no root the left, and there is no root the right, so I read the push path. So it will be something like that, and that's it basically. And I know recursions, the problem with recursion that you need to describe and just to walk through each function and how each function worked. But I will tell you something that with time and with just try to solve a lot of easy problem, specifically in recursion, it will become some sort of easy habit, second nature for us. So we don't need for the future to describe what all of that happened. But right now we are describing everything, so we make sure that we understand it very good. And that's it for today's video. And I just want to make sure that if you find my description or my solution for this problem wasn't easy enough, or my word wasn't that specific enough, feel free to give me a comment. Maybe I will do a video again about recursion, because it's a really important topic about recursion, and I don't want anyone to be left out. So if you like my solution, make sure to subscribe, hit the notification bell so you'll never miss a video, and see you in future problems.